Welcome to another episode about the series of the conversion of boats or RVs into hybrid or full electrics. In this episode, we are going to talk specifically about the criteria to select the battery bank and the criteria to select the solar panels and the procedure to calculate the gauge of the wires, the gauge of the cables in between the battery bank and the inverter charger. Okay. There are different options. Remember that we mentioned in the previous episode that you can convert only the propulsion system of your boat into electric or hybrid, or you can convert only the house into electric or hybrid, or you can convert both of them. For the propulsion system, I explained in other episodes the process and the criteria to select the electric motor, the proper electric motor to replace the original gas or diesel engine. Today we are going to be concentrated in the battery bank of the house and the battery bank of the propulsion system. Suppose that my decision is convert the propulsion system into electrical and convert the house into hybrid or full electric, both of them, the entire boat. Okay, in that particular case, probably I will have two battery banks, one battery bank for the propulsion system and other battery bank for the house. Okay, in this example, the motor that I founded for this particular boat, this example is good for a boat in between 30, 35, maximum 40 feet, sailboat or catamaran or powerboat, with a motor of 4 cylinders, diesel, Yanmar, Perkins, any of those, or a small gasoline engine. In this particular example, in this particular boat, the criteria was that electric motor, 10.0 quite torque, produced for electric yachts. And okay, that motor, that electric motor is a 3-phase motor. And the 3-phase motor, of course, depends on the inverter, and the inverter receives the power from the battery bank. And the battery bank required for this electric motor is 48 volts. Okay, if I have 48 volts in the battery bank of the propulsion system, it's good idea select 48 volts for the battery bank in the house, because if I don't have enough space in the roof, I only have one array of solar panels, only one. With that array of solar panels, probably I can charge both battery banks. If not, if I have a catamaran and I have enough space on the roof, probably 2 group of solar panels, probably I can dedicate one group of solar panels for the propulsion system and the other group of solar panels for the house. And probably one group is in 48 volts and the other one in 24 volts. This is possible. In this particular example, because I don't have enough space, I only have the roof of this tower, I am going to use only one group of solar panels to charge both battery banks. Okay, for the house, I check, I investigate, I check a lot of reviews in different manufacturers, and I found that a great option is this battery, the battery Dakota, 48 volts, 96 amps. Remember, power is equal voltage times intensity. This is why the power in this battery is 4800 watts. And I bought 2 of those batteries to create a battery bank for the house. I want to connect those batteries in parallel. Okay, those 2 batteries in parallel, each one 48 volts, 96 amps. In that case, the output of that parallel will be the voltage stay constant, 48 volts, and the amps increase, 192. Okay, it's approximated 200 amps. That's great. This is the battery bank for the house. In the propulsion system, I connect two batteries of 24 volts in series in order to get 48. Of course, the battery that I select, the capacity in amps is small, but this is only for learning purposes. Probably in a real boat, I need more capacity in amps, more output power. Okay, great. I have the propulsion system in 48 volts, and I have the house also in 48 volts. 48 volts, if those two batteries in parallel, 48 volts, is a lot of energy for this small boat. In this small boat, I am going to use that small inverter charger, Victron. It's 2000 watts, 120 volts, 30 amps. Is that the capacity of that inverter? And that inverter is excellent for a panel like the panel that I have, with a main breaker of 30 amps and 5 branch breakers. Of course, this battery bank, the capacity is this battery bank is probably good for a panel with a breaker of 50 amps and 120 volts single phase. That's too much, probably 6 kilowatts for that group of batteries. In this particular case, I have a good battery bank, and now I am going to explain the process to calculate the gauge of the wire. Before of that, let me mention something about the solar panels. Be careful when you dimension the battery bank. Of course, it's a great idea if you storage more and more amps, because this is better for the house, it's better for you and your family in the boat. But be careful with the decision about the solar panels. And because remember, if my decision is, oh, I want an RV or I want a boat full electric, what is the meaning of that? That practically the life in my boat, the life in my RV depend exclusively of the capacity of the battery bank, and of course the capacity of the solar panels. And also, if the solar panels arrive, the capacity is too small, probably need a lot of time to recharge the battery bank. Remember, the full electric RV or the full electric boat is a boat that depend on the solar panel or depend on the shore power connection. Okay? All right. Be careful when you dimension the battery bank, because this dimension should be according with the capacity of the solar panel array. What is the criteria in that particular case? Remember that in our classes of electricity, we explained that a good battery charger for this group of batteries, for this battery bank, is a battery charger that the capacity in amps is 10% of the total capacity of the battery bank. This is the minimum charger required for that battery bank. For example, if I have a battery bank that in total have 600 amps, I need alternator or a battery charger with an output 60 amps. What is the meaning of that? That with this charger, battery charger or alternator, I can charge this battery bank. I can recover the charge in this battery bank in 10 hours if the battery bank is fully discharged. Of course, you never discharge the battery bank completely. Remember, if the battery bank is in lead acid or gel or AGM, discharge the battery bank no more than 50%. The new technologies like this one, lithium phosphate, you can discharge more. I recommend no more than 70%. Okay, because you protect the battery, and also because it's easy to recover the level of charge in the battery bank. Okay, in this particular case, you need to be careful that your solar panel array, the capacity to storage and produce energy that a solar panel array should be, in my opinion, 10 is not good. 20% of the capacity of the battery bank. What is the meaning of that? That you can recover your battery bank if the battery bank is fully discharged with this group of solar panels in 5 hours. Okay, Okay, this is a good criteria because in a typical day, 5 hours is a good average for a good sun, good light. Okay, don't forget, the capacity of the solar panels should be 20% of the capacity of the battery bank. In that way, you can recover the battery bank in 5 hours in case that the battery bank was discharged completely. This is the criteria, 20%. Okay, what number is good to take that decision? The power in watts or the amps, the capacity of the battery to storage amps, or the capacity of the solar panel to produce amps? Okay, in both of them are okay. In this example today, we are going to use the criteria of the watts. How many watts I need in my solar panel array according with the capacity of my battery bank in watts. It's simple. This is the process to select the proper solar panel array for this group of batteries. And this is the area where the people make a lot of mistakes. Probably the battery, the group of solar panels is not enough to charge this battery bank in the period of time where the sun is producing energy. And at the end of the day, the people say, no, I don't like this design. I never recharge my battery bank with this group of solar panels. I need other options to recharge my battery bank. To avoid that, minimum, the capacity of this solar panel array should be 20% of the capacity of the group of batteries. Okay, we are going to analyze this particular example. We have two batteries of 4,800 watts each one, connected in parallel, times 2. This is 9,200 watts, the capacity of my group of batteries. Okay, this is the battery bank. Okay, in my solar panels, I have those solar panels. The capacity, the output capacity of those panels is 220 watts. The PV, 220 watts each one. Okay, and I am going to connect those two panels in series. Okay, we are going to double the power. The power will be 440 watts. Okay, if you see 440 is less than 10% of 9,200. 9,200 is the capacity of the battery bank, and 440 is the capacity of the solar panels. The capacity of the solar panels is not 10%, it's 9% of the capacity of my battery bank. What is the meaning of that? I need probably 12 hours to recharge my battery bank if the battery bank is fully discharged with this group of panels. In that particular case, I need more panels. The recommendation is 20%. A good number is 20% of 9,200. Let me check how much is 20%. Times 0.2 is 1,800 watts. I need create for this group of batteries, 9,200 watts. I need create a group of solar panels of 1,800 watts. Okay. Of course, power is equal voltage times intensity. I am going to create that group of solar panels in 48 volts. Okay, it's 1,800 divided by 48, and this is the capacity in amps that I need in my solar panel array. Okay, this is the criteria, and I hope you understand that explanation is too simple. How much power I have in the solar panel, how much power I have in the battery bank. Okay, the power in the solar panel should be 20% of the power of the battery bank to stay happy, to recover this battery bank if the battery bank is fully charged, with that solar panel array, I can recover in 5 hours my bank. Okay, this is a good number. Depend of the condition, depend of the weather, depend of a lot of factors. 5 hours is good. Okay, this is the criteria. In this particular case, I select in this example those batteries of 48 volts, 96 amps each one, and we are going to use a small inverter, the Victron inverter, 2000s, 120 volts, 30 amps, and we are going to fit that AC panel with a main breaker of 30 amps and 120 volts single phase. The distance, now we are going to calculate the gauge of the wires that we are going to use in between the battery bank and the inverter. The inverter is considered the load, and the battery bank is the source of power. Okay, there are different ways to calculate the gauge of those wires. We are going to use one calculator, wire calculator. In this particular case, I have the Omni calculator, and I was conservative. This battery bank has the capacity to produce 200 amps, to storage 200 amps, but in this small inverter, we don't need 200 amps flowing constantly. We don't need 100. Okay, I am going to be conservative. I am going to use 150 amps, and the distance in between the battery bank and the inverter is 8 feet, one-way distance, 8 feet, and I put the maximum temperature. This is an exaggeration, and according with this information, the cable recommended is 10. Okay, and this is the wire, the gauge of the wires that we use in between the battery bank and the Linux bus bar. Okay, with those wires, we are going to fit. With those wires, we are going to fit from the negative of my battery bank, passing through this shunt. I installed this shunt here because I want to monitor the condition of the batteries. Remember that I want to create this project hybrid. What is the meaning of that? I want that when the level of charge in the battery bank decrease 20%, the Servo GX send a signal to start the generator. The generator will be located here, and the generator start, supply power for the inverter charger, and the charger will charge the battery bank and recover the level of charge. This is the idea. This is why I install that element, intelligent, and also I am going to install here a DOD level indicator. Yeah, you remember the DOD to know how much is the percentage of charge in the battery bank. Because I want to be sure that when the battery bank decrease the level 20%, immediately start the generator to recharge the system. This is the perfect hybrid mode. Okay, and I pass the cables, I pass the wires. Finally here I have the connection. I have the positive switch selector to activate the positive bar in the links distributor and in the link shunt, and the negative also here. And now the next step will be the connection in between the links distributor and positive negative entering in the inverter. And also we are going to bring the power coming from the solar panel array entering in the MPPT, and from the MPPT entering in the links distributor. This one will be the topic for the next coming episode.